name is Connor Hollins, and today I'll be walking you through various non-destructive inspection methods that are crucial in ensuring the safety, reliability, and cost efficiency of our aviation maintenance programs. This presentation will cover the pros, cons, and costs associated with these techniques and how they can be practically applied in scheduled maintenance programs. Non-destructive inspection, or NDI, refers to techniques used to assess materials and components without causing damage. In aviation, NDI is crucial for identifying hidden defects like cracks, corrosion, and delaminations that could lead to failures. By detecting these issues early, we can avoid unexpected repairs and downtime, ensuring aircraft are safe for flight while minimizing operational disruptions. NDI also supports proactive maintenance, extending the service life of our fleet and ensuring we comply with regulatory standards. Ultrasonic testing uses high-frequency sound waves to detect internal flaws and measure material thickness. It's highly effective for materials like metals and composites, providing a deep look at potential weaknesses inside parts. However, it requires skilled technicians to interpret the results accurately, and it can be difficult to apply to irregular shapes. Although it has high initial cost, the long-term benefits in detecting hidden flaws before they cause serious problems make it an indispensable tool in aviation maintenance. Radiographic testing uses X-rays or gamma rays to create images of internal structures, much like the X-ray of a human body. This method is excellent for inspecting critical parts like welds and joints that are often hard to inspect otherwise. While it provides detailed imaging, it does come with safety concerns due to radiation exposure, requiring special facilities and equipment. The high setup and operational cost means it's typically reserved for more critical or high-risk components. Eddy current testing generates electrical currents in conductive materials and measures disruptions caused by flaws. It's a fast and non-contact method ideal for detecting surface cracks or corrosion, particularly in metals. The main limitation of this is its shallow penetration depth, which means it's not effective for deep internal flaws. However, its speed and ability to detect near-surface defects make it a go-to option for routine checks of parts like aircraft skins and fasteners. Magnetic particle testing and dye penetrant testing are simple, cost-effective methods for detecting surface flaws. Magnetic particle testing uses magnetic fields to reveal cracks in ferromagnetic metals, while penetrant testing uses dye that penetrates surface defects and makes them visible under UV light. Both methods are fast and portable, making them ideal for routine checks. However, they are limited to detecting only surface defects and require clean, accessible surfaces for accurate results. Visual inspection is the most basic NDI method, involving the technician's eye and magnifying tools to spot surface defects. It's quick and low cost, but only identifies visible flaws. Thermographic testing, on the other hand, uses infrared cameras to detect temperature variations caused by subsurface defects, such as delaminations or voids. While it's a non-contact method, it requires environmental control and it can be costly, but it's invaluable for inspecting large composite structures and detecting hidden issues. Acoustic emission testing listens for sounds emitted by growing defects such as cracks or corrosion as they occur during service. This makes it an ideal method for real-time monitoring of high-stress components. As aircraft increasingly use composite materials, more advanced NDI methods like image fusion are emerging to address this unique challenge of inspecting composites, such as detecting delamination or fiber misalignment. These techniques offer more precise defect detection in modern aircraft. When selecting an NDI method, the key factors to consider are the component's criticality, material type, access for inspection, and how often the component is inspected. More expensive methods are ideal for high-risk components, while simpler, low-cost methods are better suited for routine checks. The goal is to find the right balance between cost, detection depth, and skill required to operate the equipment, ensuring maximum efficiency and safety. So here's a plan in terms of recommendations and program implementation for our maintenance organization. Let's build on the NDI program we already have by adding in newer technologies such as artificial intelligence and automating some of the inspections. We'll start small with the high priority parts, and as we see how they work, we can expand this across the fleet. Also, using predictive maintenance could really help us catch issues before they even happen. And of course, we'll make sure our maintenance technicians are well trained and check that the costs of these upgrades are worth the investment in the long run. Thank you very much for listening to my presentation on non-destructive inspections, and have a great day.